Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. Today we're going to be starting Unit 6, Lesson 1. Don't forget to put your first and last name, period, and the date in the upper right-hand corner of your paper. Our topic for today is simplifying radical expressions. So all of Unit 6 is going to be covering radicals, from graphing radical functions, solving radical functions, simplifying radical expressions, all kinds of fun stuff. So our objective for today is I will simplify radical expressions and rationalize the denominator of fractions. Mastery will be demonstrated by scoring at least 80% on the extra practice. So on your paper, if you're not doing this on the printed PDF, then make sure that you have this written down somewhere. We need to talk about the nth root of A. So far what we've dealt with in our radicals is we've dealt with square roots. Well, today you're going to see, and throughout this unit, you're going to see like the third root of a number. You're going to see the fourth root of a number. And a square root of a number is technically has an index of 2. The number right here is a 2. So whatever n is, that's what we call our index. That tells us what root we're taking of that number A. So when we have a square root, normally we just write it as A, but technically there's a 2 for our index. All right. So we've already kind of simplified rational expressions that have square roots. Remember, we just look for a group of 2 under the radical. So for the square root of x squared, you would have x times x. Well, there's a group of 2 x's, so I bring that out in front of the radical, which leaves nothing left in the radical except for 1, but the square root of 1 is just 1. So we have x. The square root of x squared is x. So now you're going to do the same thing for part B. You're going to write 50x squared out in prime factors. You're going to look for groups of 2, bring those out in front of the radical, and then leave what's left under the radical. Go ahead and give this a shot on your own. So you should have rewritten 50 as 25 times 2, x squared is x times x. 25 is really 5 times 5 times 2 times x times x. We have a group of 2 5s, a group of 2 x's that we're going to bring out. So you should bring out a 5, an x, and then leave 2 under the radical. So our final answer is 5x root 2, or 5x times the square root of 2. So then when you get to part C, you're going to notice that our index this time is 3. So this time, instead of looking for a group of 2, you want to look for a group of 3 under the radical. So look for a group of 3. So when I break down 343, here's a hint, 7 goes into that. 7 times something. Then break down x to the 4th and y cubed. Look for your groups of 3. Bring out what represents that group of 3 in front of the radical, and then leave what's left under the radical and see what you get. Go ahead and just try to do this on your own. See what happens. So you should have found that 7 times 49 is 343. X to the 4th is really 4 x's times each other. Y cubed is really 3 y's times each other. All of that's being multiplied. Then I'm going to rewrite 49 as 7 times 7. So I've got a group of 3 7s. I've got a group of 3 x's with 1 left, and a group of 3 y's. So I'm going to bring out a 7, an x, a y, and then under the radical, under the cubed root, I still have this x. So my final answer is 7xy times the cubed root of x. What about the 4th root of m minus n to the 4th? Well, there's a couple ways you could think about this problem. m minus n to the 4th is the same thing as m minus n times n minus n times m minus n times m minus n. Well, I've got a group of 4 m minus n's, so I can bring that out in front of the radical, and nothing would be left inside of the radical. The other way you could have thought about this is, remember how if you take like the square root of x squared, the root and the square cancel each other? Well, the same thing happens for the fourth root and the fourth power. So if you have the fourth root of the fourth degree, those cancel and you're just left with what's in the radical, which is n minus n, which matches our answer too. All right, go ahead and do part E on your own. You're taking the cubed root of -8, x to the 7th, y to the 5th. Go ahead and give it a shot and see what you get. All right, so when I break down -8, -8 is the same thing as -2 times -2 times -2. X to the 7th is 7x's, 6, 7, and then y to the 5th is 5y's. I'm going to look for groups of 3. I've got a group of 3 -2's. I've got a group of 3x's, another group of 3x's, and a group of 3y's. And it leaves me with 1x and 2y's under the radical. So your final answer should be -2x times y times the cubed root of xy times y, or -2x squared y times the cubed root of xy squared. Hopefully you got the same answer. All right, so for F, you have the fourth root of x to the 4th over 81. So what I recommend you do is you can actually rewrite a radical, like the radical of a fraction. If the whole fraction is underneath that radical, you can split it into 2. So you can split it into the fourth root of x to the 4th over the fourth root of 81. And then simplify your numerator and your denominator. So the fourth root of x to the 4th, well, remember the fourth root and the fourth power cancel each other, so you would be left with x. And you can double check that by just thinking about, well, x to the 4th is 4 x's. There's a group of 4 x's. I can bring that x out of the radical and nothing would be left. Then the fourth root of 81. Well, 81 can be broken down to 9 times 9. Okay, we still have x over 9 is 3 times 3. And then 9 is 3 times 3 again. So I've got a group of 4 3's. I'm going to bring that 3 out in front of the radical and nothing would be left under the radical. So I don't need it anymore. So my final answer. Before we start example 2 and multiplying radicals and then simplifying our final answer, we need to go over a definition. So if you have 2 radicals, so if you have like the nth root of a and the nth root of b, and those are real numbers, then if you take the nth root of a and you multiply by the nth root of b, because the indexes are the same, you can actually take these and combine them under one radical, but still multiplying a and b. So the nth root of a times the nth root of b is the same thing as the nth root of a times b. So we're going to use that to help us simplify some radicals. So the third root of -4 times the third root of 2. Well, both of these have the same index, so we can rewrite this under one radical, the cubed root of -4 times 2. So -4 times 2 is -8. And we've already talked about how 8 is really 2 times 2 times 2. Well, then -8 is -2 times -2 times -2. So notice when your index is odd, you can take the root of a negative number. Unlike when we were square rooting, and then we would use imaginary numbers. But because we're dealing with an odd index, we don't have to use imaginary numbers, because -2 times -2 is 4 times -2 is -8. So I've got a group of 3 -2's. I'm going to bring that out in front of my radical. And my final answer is -2. For part B, the third root of 4 times the third root of 16, go ahead and give that a shot on your own. So because the numbers are both under the same index, the cubed roots of 4 and 16, we can go ahead and combine them under one radical, multiplying 4 and 16. 16 I can break down to 4 times 4. I've got a group of 3 4s. I'm going to bring that out in front of the radical, and I'm left with 4 as my final answer and nothing left under the radical. Now, when you look at example C, some like red flashing lights should go off in your mind, because if you have the cubed root of 6 times the square root of 2, these do not have the same index and cannot be combined under one radical. So your answer is just the cubed root of 6 times the square root of 2. All right, why don't you go ahead and give part D, E, and E a shot on your own. Go ahead and do both of these examples. So multiply the 4th root of 7 times the 5th root of 7. And then for part E, you're going to multiply those two square roots by each other and simplify your final answer. Press pause and then press play when you're ready to check your work. All right, so you should have went ahead and actually, I was about to skip part D. For the 4th root of 7 and the 5th root of 7, because they're under different radicals, we can't combine them into one. So our final answer is just what the problem was. For part E, they are both under square roots, so we can combine all of this good stuff. So I multiplied the 72 by the 10, the x cubed by the x, the y squared by the y cubed. And then I just looked for my pairs. So I ended up being able to bring out a 6, a 2, 2 x's, 2 y's, and then I was left with 5y under the radical. I went ahead and multiplied. I got 12x squared y squared times the square root of 5y. All right, now let's talk about division. So now we're going to be dividing radical expressions and simplifying our answer. But first we need to talk about a definition. So again, if you're taking the nth root of A and the nth root of B, but this time B is not allowed to be 0, then if you take the nth root of A and divide it by the nth root of B, that is the same thing as the nth root of A over B. So we kind of already used this definition in an earlier example in part 1, but this is just the formal, like formally stating that. So as you can see, B is not allowed to be 0 because, hey, it's in a denominator and our denominators can't be 0. So that's why we stated that restriction in the definition. And again, we're dealing with the nth root of A and the nth root of B being real numbers. All right, so if you take the nth root of something and you divide it by that same root of something, you can rewrite them under one radical. And this also works the other way, like vice versa. So if you start with an nth root that looks like this, you can separate them into 2 radicals. Still using division. So here's why we want to do that sometimes. So we have the square root of 18 x to the 5th divided by the square root of 2x cubed. And what I notice is that 18 is divisible by 2, and that x to the 5th and x cubed would simplify. But they're both under radicals, so I can't just start simplifying things. Instead, because of that definition we just talked about, I can actually rewrite these as the square root of 18x to the 5th over 2x cubed. So combining them under one radical actually helps me simplify the problem. It makes it a little easier. So now when I take 18 divided by 2, I get 9. X to the 5th divided by x cubed. Well, x to the 5th is really 5 x's. X cubed is really 3 x's. X divided by x is 1, x divided by x is 1, and x divided by x is 1. So now I have 9 times 1 times 1 times 1 times x times x. And my denominator completely canceled. So I'm left with the square root of 9 times 1 is 9 times 1 is 9 times 1 is 9 times x, which is x squared. Well, check it out. What's the square root of 9? 3. What's the square root of x squared? X. So my final answer is 3x. All right, for part B, the cubed root of 162 y to the fifth divided by the cubed root of 3y squared. See if combining these two radicals under one radical would help you simplify the problem further. Go ahead and give this a shot on your own. See how far you can get. All right, so as you can see, I rewrote it. I put a large cubed root. I made sure that the whole fraction could fit under that single cubed root. Make sure your work looks like mine. 162 divided by 3 is 54. Y to the fifth divided by y squared is y cubed. So I'm left with the cubed root of 54, y cubed. So combining them under one radical helped me simplify this problem further. Well, 54 is 9 times 6. So I have a cubed root. I'm looking for groups of 3. 9 is 3 times 3. 6 is 3 times 2. And then y cubed is 3y's. I've got a group of 3 3's, a group of 3 y's. I'm going to bring those out in front of my radical. And then I'm going to leave the 2 under the cubed root sign. So that means that the cubed root of 162 y to the fifth divided by the cubed root of 3y squared simplifies to 3y times the cubed root of 2. All right, let's do some more examples. So now when we get to part C. So for part C, we have 5x squared over 12y squared z. This fraction is already under one radical, but it can't be simplified. Like the fraction can't be simplified. So to make our lives easier, this time we actually want to split it and break it back up into 2. So we're going to have the square root of 5x squared divided by the square root of 12y squared z. And now we're going to see if there's anything that we can simplify. Well, the square root of x squared is x, and I know that because x squared is x times x. I can break 12 down to 4 times 3. Y squared is y times y. And so in the numerator, I can bring out an x in front of that radical, leaving 5 under the radical. The square root of 4 is 2. And then I can bring out a y because there's a group of 2 y's here. And then I'm going to leave 3z under the radical. Well, we're actually not done with this problem because we have to do something that's called rationalizing the denominator. We are not allowed to leave radicals in the denominator of a fraction. So don't leave radicals. It's just considered improper. So to get rid of the radical, we're going to do something that is called rationalizing the denominator. And to do that, you just multiply the numerator and the denominator by the radical that's in the denominator. So this radical is 3z. So I'm going to multiply it by radical of 3z, top and the bottom. When you write your z's in math, please put a line through them so we don't confuse them with 2's. All right, so let's see what happens. Well, what happens is you get x. The square root of 5 times the square root of 3z is the same thing as 5 times 3z, which is 15z, all over 2y root 3z times 3z is 9z squared. We'll check out what is about to happen. So I'm going to have x root 15z all over. The square root of 9 is 3, and the square root of z squared is z. That brings everything out from under that radical. So we're going to have 2 times 3 times y times z, and nothing's left under the radicals. The radical completely simplifies out of our denominator. And then, of course, we're going to rewrite this. 2 times 3 times y times z is 6yz. And there we go. Now, some of you may be tempted to divide this z by this z and cancel them, but we can't do that because This z up here is under a radical. So, and this z isn't. So they're not the same thing. We can't divide them by each other like that and get 1. All right, why don't you go ahead and give root 3 over root 5 a shot. Actually, why don't I do this one with you? So if we combine these under one radical, the square root of 3 over 5. 3 over 5 isn't going to simplify. So combining them under one radical didn't really help us. So we want to leave them separated. But it's bad form to leave this radical in the denominator. So what do? We multiply the numerator and the denominator by that radical. So root 5. And what do we get? Well, the square root of 3 times the square root of 5 is root 15. Then root 5 times root 5 is root 5 times 5. Well, hey, there's a group of 2 5s under that radical. Bring it out. So root 15 over 5 is our final answer. There's no longer a radical in the denominator, so it's in proper form. And remember, this 15 is under a radical. And some of you might be tempted to divide the 5 into that 15, but you are not allowed to do that because the 5 is not under a radical anymore. So why don't you go ahead and give 2 root 6 a shot on your own. See what you get. So I bet you were able to take the numerator and the denominator and multiply them both by root 6. So root 2 times root 6 is root 12. Root 6 times root 6 is root 6 times 6, which simplifies to 6. So root 12 over 6. But root 12 can be simplified further because 12 is really 4 times 3. And the square root of 4 is 2. We can bring that out in front of the radical, and we get 2 root 3 over 6. Now, because both the 2 and the 6 are outside of the radical, we can go ahead and simplify 2 over 6. Well, 2 divided by 2 is 1. 6 divided by 2 is 3. So 2 6 simplifies to 1/3 root 3. 1 times root 3 is root 3, and then over 3. Remember, you cannot simplify that further because the 3 is under the radical, and this 3 is under a radical, and this one isn't. So we're going to leave our final answer like this. All right. Explain the error in the simplification of this radical expression. Root 2 times cubed root of 6 is equal to the square root of 12, which then simplifies to 2 root 3. What is the error that was made in this problem? So hopefully you figured out that this person should not have combined these two radicals under one radical because this index is 2 and this index is 3. So because the indexes aren't the same, we can't combine them under one radical. All right, now let's do some addition and subtraction. So we're going to add and subtract some radical expressions. So when we add or subtract radical expressions, it's kind of just the same as adding and subtracting a regular expression where you can only combine like terms. So the bases have to be the same. So what we do is we treat the radical like a base. So the square root of 5x and the square root of 5x are the bases of these numbers. So 3 root 5x minus 2 root 5x can be combined because the bases are the same. It's the same as like combining 3x and 2x. So 3 minus 2 is 1, and then you keep the base of 5x. So the answer is 1 root 5x or just root 5x. So part B, 6x root 7 plus 4x root 5. These cannot be combined because this base is x root 7 and this base is x root 5, and they're not the same. So our final answer is actually just the expression as it was written. 6x root 7 plus 4x root 5. It's the same thing as like not being able to combine x squared and x because they don't have the same base. All right, let's try 12 root 7xy minus 8 fifth root 7xy. What would our final answer be? Well, again, these bases aren't the same. One of them is a square root, the other is a fifth root. So our final answer is the expression itself with no changes made to it. All right, part D, 3x root xy plus 4x root xy. Are the bases the same? Can we go ahead and add these two? Go ahead and answer this question yourself. So 3x root xy plus 4x root xy do have the same bases. 3 plus 4 is 7, so we have 7x root xy. All right, part E. So we have the square root of 12 plus the square root of 75 minus root 3. And right off the bat, you might want to say, well, Ms. McGuire, we can't combine these because root 12, root 75, and root 3 don't have the same bases. Well, what if we can make them have the same bases? So the square root of 12, can't they be simplified? The square root of 12 is the same thing as the square root of 4 times 3. 75 is 25 times 3. And then 3 is prime, so we're done with that. Well, hey, 4 has a square root, 25 has a square root. The square root of 4 is 2, so root 12 is really 2 root 3. The square root of 25 is 5, so that's really 5 root 3 minus root 3. Well, check it out. Now they all have the same base of root 3. And remember, minus the root 3, there's technically a 1 out there in front of that root 3. So 2 plus 5 is 7, minus 1 is 6. Our final answer is 6 root 3. All right, let's try F. So the cubed root of 250 plus the cubed root of 54 minus the cubed root of 16. Right off the bat, you might say, well, Ms. McGuire, these don't have the same bases. All the radicals are different, but what if you could simplify them? So simplify these bases, see if they end up being the same, and if you can combine them. Go ahead and give this problem a shot on your own and see what you get. So I was able to simplify all of these cubed roots. I broke 250 down, as you can see. I found a group of 3 5s. I broke down 54. I found a group of 3 3s. I broke down 16. I found a group of 3 2s. I brought out those groups of 3 out in front of my radical. And then that left me with cubed root of 2 as my base for each of these expressions. Then I could add the 5, the 3, and subtract the 2, which is 6 cubed root 2. Hopefully our answers match. All right, we are almost done. This is the last example. I know there's been a lot of information in this lesson, and I'm sorry for that, but we don't have a lot of time for Unit 6, so we kind of had to do a lot today. All right, so for example 5, we're going to take 4 plus 2 root 2 times 5 plus 4 root 2. So just like if we had 4 plus x times 5 plus x, we would distribute. Same thing goes for these guys. We're just going to do a whole bunch of distribution. You're going to take the 4, distribute it to the 5 and the 4 root 2. Then you're going to take the 2 root 2 and distribute it to the 5 and the 4 root 2. So 4 times 5 is 20. 4 times 4 root 2 is 16 root 2. I just multiplied the numbers outside of the radicals and then kept the radical as my base. Then 2 root 2 times 5 is 10 root 2. 2 root 2 times 4 root 2 is 2 times 4 is 8. Root 2 times root 2 is root 4. Then we're going to simplify as much as we can. So we have 20 plus 16 root 2 and 10 root 2 are like terms, 26 root 2. Then 8 Well, the square root of 4 is 2. So this is really 8 times 2. So 20 plus 26 root 2 plus 16. Then you add 20 and 16, right? 36 plus 26 root 2. And for these final answers, you always want to leave the radical, the term with the radical, you're going to write that second and put 36 out in front. All right. So why don't you go ahead and take a turn. Take 3 minus root 7 times 5 plus root 7. Distribute that 3. Then distribute the negative 7 and see what you get. All right. So 3 times 5 is 15. 3 times root 7 is 3 root 7. Negative root 7 times 5 is negative 5 root 7. Negative root 7 times positive root 7 is negative root 49. I simplified it. I combined these two like terms. The square root of negative, this negative of the square root of 49 is negative 7. 15 minus 7 is 8. And I got 8 minus 2 root 7. And do it one more time. So do 3 plus 2 root 5 times 2 plus 4 root 5. Go ahead and give this one a shot on your own as well. Press pause and then press play when you're ready to check your work. All right, so 3 times 2 is 6. 3 times 4 root 5 is 12 root 5. 2 root 5 times 2 is 4 root 5. And then 2 root 5 times 4 root 5. 2 times 4 is 8. Root 5 times root 5 is root 25. Then we need to simplify. So combine your like terms. 6 plus 12 plus 4 is 16 root 5. 8 times root 25 is the same thing as 8 times 5. 8 times 5 is 40. 6 plus 4 is 46. So 46 plus 16 root 5. Hopefully our answers match. All right. Then we're going to multiply 5 root 7 times 5 plus root 7. Well, check it out. Both of these numbers are the same. The radicals are the same. The only difference is the negative and the positive sign. I wonder if something interesting might happen, like something we've seen before. Maybe like what happens when we multiply x minus 2 times x plus 2. All right, well, let's start multiplying. 5 times 5 is 25. 5 times root 7 is 5 root 7. Negative root 7 times 5 is negative 5 root 7. Negative root 7 times root 7 is negative root 49. Oh, hey, what happens here? 5 root 7 minus 5 root 7? Isn't that just 0? So we're left with 25 minus the square root of 49 is 7. 25 minus 7 is 18. The middle terms canceled. The radical ended up dropping out, and we're left with an integer. Interesting. I wonder if that'll happen again. Like if we multiply 6 minus root 12 times 6 plus root 12. What do you think is going to happen here? The radicals are the same. These first numbers are the same. The only difference here is we have a negative and a positive. All right, why don't you go ahead and multiply this one on your own and see if our answers end up matching. Go for it. All right, so 6 times 6 is 36. 6 times root 12 is 6 root 12. Negative root 12 times 6 is negative 6 root 12. Negative root 12 times root 12 is negative root 144. These two terms end up canceling. The square root of 144 is 12. So I'm left with 36 minus 12, which is just 24.